This is the Glitch Panopticon Season 3 Chapter 3. In this episode, we will be speculating about the implications of the conduit universe theory of entanglement as explained in the last podcast. To start out, entangled electrons which emit light simultaneously have been shown to reveal an interference pattern which reflects the nature of their entanglement. See Aviv Carnielli, Professor Airy, Professor Kaminer, and Nicholas Rivera, Physical Review Letters. This may support the conduit theory. But if conduit theory is true, it means that quantum entanglement permits transmission of light which does not pass directly through the intervening space. However, the light itself never travels faster than c. This means that the impact of redshift would be diluted by any entanglement. This means that the light that we observe demonstrating redshift may in fact not be a proper measure of the distance between point A and point B. In other words, everything we see might actually be even further away from us than we think it is. This would also mean that the cosmological constant, calculated with the redshift in mind, would not be accurate, given travel through conduit universes. All of this may suggest that the calculations of dark matter and energy, which go into the cosmological constant, may not be accurate as well. I would suggest if there is evidence in support of the conduit universe theory, it might overturn major conclusions about the nature of our universe. To return to the conduit universe theory, we indicated that the conduit universe exists like a wormhole between two entangled particles. Through this information can pass from the general to the particular. That is, light can travel between two spatially disconnected points through the conduit universe wherein those points are at the same location. This preserves the limit on the speed of light, while representing the transmission of information from classical, relativistic space to the quantum realm. In effect, it is as between two quantum entangled particles, light travels without passing through the intervening space. This information, or light, represents the collapse of the wave function and decoherence. One such study, a peer-reviewed paper from Tel Aviv University, by the same authors, the researchers demonstrated how light waves change, depending on the quantum properties of the particles emitting them, and that this light emission can be interpreted as the manifestation of a counterintuitive quantum phenomenon, the collapse of the wave function. In other words, the collapse of the wave function follows light emission of quantum entangled particles, giving credence to the above conduit theory. Likewise, quantum entanglement is known to create wormhole stability, which suggests wormholes and quantum entanglement coexist with some regularity in nature. See Journal of High Energy Physics, Pingao 2017. Finally, it is also clear that microscopic wormholes are the most common form suggested by relativistic mechanics. This goes further toward the suggestion that such wormholes are common in nature. That's the end of the podcast for today. If you enjoyed it, please like, comment, and subscribe.